Hello Patreons, this is Korben from korben.info. Glad to see you for a new video. In this video, I'll discuss HTTP and SOCKS tunnels. You'll see. We'll see how we put this in place and what it's for. But before, I'd like to thank all who watch, Patreons who support on patreon.com. Thanks, because it's thanks to you that I can create videos, feed korben.info, and share my discoveries on social media. Thank you. To join us, don't hesitate. You can find Korben on Patreon. The link is below the video. Join us to access all the wonderful content in preview, newsletters, etc. So, before going into detail and giving you a demonstration, what is an HTTP tunnel used for? If you know VPN, you'll quickly grasp how it works. But basically, it lets you start from machine A and access machine B through an encrypted channel that's protected, and everything that passes through is not visible. Here it is, that's the VPN concept, except now we'll learn to implement it ourselves for various purposes. So, what can we do with a tunnel like this? Well, we can bypass firewalls. This means that, for example, if you are on a restricted network without internet access, you can use this tool to create a tunnel between your current machine and an external machine. This allows you to access the internet through the network by routing your traffic through the external machine. So if there are internet resources blocked by firewall restrictions or tools, etc., you will be able to unblock that thanks to this kind of tunnel. This tunnel type enables remote access to local resources, so as a developer with tools on your home machine that only run locally, you can maintain their internet inaccessibility and ensure that no one else can access them. You can set up this kind of tunnel so that when you are on a Wi-Fi network, I don't know, elsewhere, at work, at McDonald's, whatever, establish an encrypted connection to your local network, at home, and access all the services available at your home remotely. Allows like that, there you go. If you want to put in any case, why not temporarily accessible tool? You can also do like that. This tunnel is also widely used for pen testing and computer security, enabling assessment of risks such as document leaks or unauthorized access to third-party services, etc. Via this tunnel, it's totally feasible. So I clarify, for example, let's envision an attacker with access to a machine on a non-owned network. There it is. That is the machine he is targeting. And this machine has access to other open services, but only within the local network. Well, with this kind of tunnel, it allows to remotely access, on the pentester's machine, all the services that are accessible from the machine that he has hacked, in quotes, to which he has access. In countries censoring the internet, it's the same. It helps bypass censorship, like firewalls, as I was saying. For teleworking, it can also allow you to have secure access or provide this kind of access to your employees so that they can securely connect to the company network from their home without you having to expose things on the internet. We can ensure perfect security for IoT communication channels, for example, by utilizing this type of tools. Going through a third-party machine is a bit like using a VPN, exactly the same usage. You can finally anonymize your web browsing or the tools you use. There you go, same thing. If you want to access geographically limited services, for example, let's imagine a service, like a video game, only accessible in the United States. You can take a small server in the US and connect through this tunnel via the server to access the services without any problem. There you go. And if you are still in the business world, you can also, why not, utilize this type of tunnel to interconnect various sites, different locations of your company. Safely, you can connect Paris to Marseille. If you have offices in Paris, offices in Marseille, each will have access to the services of others without going through the public internet, but by passing through these tunnels. Here are a few uses. We will say generals that I present to you there. Now let's see how we implement this technically. So there are plenty of tools to create tunnels, but the one I'm going to present to you now is this one, Chisel. So Chisel, it's a tool developed in Go, in Golang, which is recent, a few years old, and aims to be secure, fast, in short, awesome. No questions, just learn how to use it. Here we have a diagram showing how it can work. I will make an effort to zoom it in a little bit if possible. Here you go. It is a transmission control protocol user datagram protocol tunnel, and it has the capability to transport via hypertext transfer protocol and secure with secure shell. We can open several tunnels like this per TCP connection and access the Chisel server. On one side we have the Chisel client that is launched. It establishes a tunnel with the Chisel server, and both offer access in both directions. To install it, it's not complicated. You can simply get the binary, make it executable with chmod++. Binaries available on Windows, macOS and Linux. In all architectures we have ARM, ARM64, AMD, x86. You will definitely find what you are looking for, no problem for your machine. Choose from a wide range of options. Retrieve binary, make it executable, no problem. Only one binary, no two different ones, no server binary. Client binary, same, except depending on launch, starts in server mode or client mode. Install it with curl command curl https://jplora.com.chisel impipe bash. It will retrieve the script and install it for you. With the exclamation point, a pipe followed by bash, it retrieves the script and installs it for you. You can launch it via Docker, and then afterwards you can also launch it directly from the sources with a go install command, and you put the GitHub repository behind it. That's it. Nothing complicated here. There's a demo, but I haven't tested it, and I don't think it works yet. I'm not sure. We're going to do tests directly on my machine and on my NAS. In terms of features, easy to use. It's always the same. It's command line, not a graphical interface either. Performant, there's a small star. I don't know its meaning, so I'll check the page, but they did benchmarks, and it's more performant than Robar, for instance, a possible competitor to Chisel, and not much higher than a direct connection. Here we have the numbers for the direct connection, and here we have the numbers with Chisel. Obviously, the more data transferred, the longer it takes, but we're not talking about crazy things either. Here we are in milliseconds, nanoseconds, and on Chisel we start from milliseconds. If you desire a tangible example, let us consider the final line at this location. Therefore, that is a total of 100 megabytes of data. If it was transferred live on the benchmark, a total of 100 megabytes were transferred in 76 milliseconds. With Chisel, 100 MB were transferred in, let's say, 1 second. We are at 966 minutes, so it's almost 1 second. That's what they say here, 100 MB in 1 sec. And with Robar, 100 MB were transferred in 36 sec. So we are not really on the same page when it comes to speed. Chisel is well positioned on speed, so that is cool. The connections are encrypted. It can also be authenticated. That is to say that you can put config files to determine whether or not we have the right to access the server with authentication keys, that kind of things. There is automatic reconnection of the client. If by the connection he tries again and reconnects. As I showed you in the diagram above, it is possible to create multiple tunnels through a single TCP connection. We can also switch to SOCKS or HTTP connect via proxies, so there you have it, why not? It performs reverse for forwarding, so that is pretty cool. It enables you to do the opposite. Usually we connect from the client to the server, and there in fact, the reverse allows to initiate the client's connection from the server basically. That's it, it allows to do the opposite. Server can act as reverse proxy, won't go into detail. If interested, check documentation, would be more advanced. Clearly, when it comes to SOCKS 5 connections, it's essentially the same thing but in reverse when it comes to the port. It is an exploration tool that does a lot of things, that provides many services, that will allow you to set up, why not, infrastructures, in any case connections between your infrastructures, ways to access your resources securely and without compromise by going through firewalls and things like that. And I'll show you how to use it. Here I have a Firefox. Let's imagine I'm on test machine, so I can't provide you with real cases. Here I have a Firefox configured with a proxy. Here he doesn't actually have internet access with this Firefox. Let's say I'm on a network. Where can I only exit through a certain port? For example, let's take port 25, which is the SMTP port, or port 53, which is the DNS port, that kind of things. I have limited access, I don't have internet access, I can't go out on ports 80 or ports 443. So I can get stuck. I have my server machine, so the server on which I installed Chisel is here. We observe it, it's there, it's just the binary that I put and made executable with chmod +x Chisel. There you go, so I can run it. And there you see I have server or client. So there, when I'm on my server, I'm going to launch it as a server. To achieve that, I'll create a .chisel, run it in server mode, specify the server command, and set the parameter to SOX5. For my browser, it will be better, and I just throw it out there to see already. So there, it creates a listening port on port 8080. Except maybe it doesn't work, port 8080 blocked by firewall. I know only port 25 goes through. I'm going to stop this and I'm going to specify through which port I want it to go. I'm going to do port and then I'm going to put 25. Remove S, no S, port 25. Pull port 25. Launching, unfortunately machine already using this port, so it's not usable. It's not serious, we'll do port 53, we'll test. Same thing, I don't have an FTP server, so maybe it will work on port 21. So on port 53, well, I shot the service, so for now I can't start it, but if I launch Chisel with the sudo command to be able to open something on this port 53, which is normally reserved, this time it will work. So I have my port 53, the DNS port, which is therefore open on my server. He's listening, I have nothing else to do on the server side. It's launched. I took this example from port 53 because DNS in general are open. In the event of domain name resolution, this type of thing is considered a classic port that commonly goes through the network. Imagine 21, imagine ports 80, ports 25 as I said. In short, it doesn't matter, 80 offset 25 as I was saying. Now I'll go on my machine locally, so here it is, I'm on my Mac, classic, mono special, enlarging the window a bit, put it on the side here, so this is my server, top left, and this is my local machine. There Chisel is also installed, so I just have to call her in client mode, and I will put the address of my server. The address, it's simple, I have a domain, mine is NAS local, but it could be 192.168, etc. I specify I want to connect on port 53, so I didn't specify I wanted to connect with SOX, so he doesn't get it. So I will relaunch the command Chisel client NAS 2.53, and there I specify the SOX parameter. There you go, this time it's good. So you saw I typed this command except I specified because he hadn't seen it was open. From there he connects. So there I have a connection established between the two machines, except that I'm not using it yet. To use it I have a proxy at 127.0.01.1080. After that, in my tools like Firefox, I go to the settings. In the network settings I open and choose the proxy 127.0.0.1.1080 as SOX5. I hurl it in this manner. Now when I visit my website there, I am able to access my website by means of my server. Not visible here in Windows because verbose mode not enabled. But if I restart server here with parameter v, there you go, and on other side same thing, restart with parameter v. Put him just before here maybe. Here, now, I have a lot more information than it shows, a lot of things are happening. And me, if I go for example here, I refresh the blog, there, hop, it opens ports, things happen. And so we see that there are connections, there are already more discussions. So from there, I actually access the internet through my server. So to summarize this first part, basically what did we do? We have a server here at her place. I will show you the command that I launched in server mode using SOX5 on port 53. As a client, I have a client that I tell him to listen to port 53. Finally, to connect to my server with port 53 in SOX. So normally I move on to trial firewall, which does not block port 53. Well, that was fun, but it's not the nicest thing to do with Chisel. What is fascinating to do on Chisel is clearly port forwarding, which refers to transferring a port to another, forwarding connections through the available ports on the system. Do this, and well, already on my server, always the same, I launch the server on port 53. I don't bother. Then I can put other ports, you put what you want. If you want to put 54,000 rather, 5430, you put 5430, that's possible too. Well, let's do that here, it will change a bit than port 53. So I launch that here on port 5430, and then I will connect with my client. So I'm doing Chisel client, the name of my machine, the name of my server, nas.local 2.5430, and then I'm going to have it redirect ports. To do this, I need to open a small port on my server. I'll show you how I do it, just for the demo. Terminal, you see it's my server here, Korben NAS. Going to launch web server in Python, open on port 8000. Well, if I do this, I can access it very easily with my browser. I don't need Chisel. All I have to do is type nas.local 2.8000 in the address bar, and I will have a, let's say, web view of the directory where I launch that command. Python, you can do this with Apache, Nginx, or whatever you want. No matter, it's just a demo. Except there, since it's accessible, not good for my example because there I already have access. So we'll modify the command, add the parameter bind 127.0.0.1. I start, it reboots the server. Yeah, same way, except only reachable from URL 127.0.0.1. So me, remotely, local NAS, no access. Well, you can't see it, but it's not loading anymore. I'm doing this, there you go, nothing is loading anymore. So now I find myself with a web server running, only accessible locally, simply. So I'm going to let him run in a corner, we don't care a little bit, it's just for the demo. Now what will interest me is to open a port to port 8000, in fact simply. So here I have my server running 5430 on the edge, 5430, nothing has changed. There is no problem. And then here I do Chisel client. I put the same thing as before, the address of my server 2.5430, except that now I will have to do port mapping. So to do mapping, I can do 127.0.0.1, 2.1, and there. So this is the part at my place. Here it's me. Which port can I open? I can open it on port 8000 or 5000 or 3000. I can do as I wish. After inputting that, I add 2 dots back, then the remote machine. So there we access the remote machine, the port, the server I want to open, the port I want to open. I access it via 127.0.0.1. So I'm saying the same thing actually, 0.01.8000. What does that mean in concrete terms? This means that my client Chisel will connect here to my remote server via port 5430, and it will simply map this local address 8000, which is on the machine I am on my iMac, to the local URL as well. Finally, the local IP and port of my server, or via the port, the running Python server. Here, I'll show you a faster way to do this later. There, it's connected. So I have a connection established between the two at port 53, and now when I access here at 127.0.0.1. Port 8000, I access my Python server, which is usually not accessible since it is only accessible locally. Now I can access it remotely easily. If I changed here and mapped the port, e.g. 2300 on port 8000, same thing. If they listen, it doesn't work. My port 8000 doesn't respond. But if I put 2300, there it responds and I have access to a protected resource. That's the whole point of the tunnel, that a resource that is normally protected behind my server, I don't have access to from the outside. I can access it easily with Chisel. So that was on, let's say, a classic operation. Now let's see the reverse. Reverse is the same, but in the other direction. So here I am on my client. Well, on my client machine, my iMac, I specify here, except that that's what I'm going to open the port on. So I'm going to make a client server, so I open the server. Except I put myself in reverse. In reverse, and here I specify my port. What did I put before? I had put 5430, I believe. I do not recall. I believe that was it. Well, never mind. We can utilize any port. There is no problem. There, my iMac is listening because I have these clients there. So it is Chisel server Rivers port 5430. There, my iMac starts listening. It's accessible, it's the one that serves as a server. Now I'm facing a threat, well on my server here. On remote machine, have small shell, can download Chisel binary and launch Chisel in client mode, telling it to connect to Mac, my personal computer with IP address 168.62 on port 5430. And now I will need to map the ports as I did earlier. Previously I used 127.0.0.1, but we can replace it with R for remote, so I'll do that. Replace actually 127.0.0.1. I noticed a bug, so I don't know if it's normal or if it's something I didn't understand well. But when we are in reverse mode, 127.0.0.1 doesn't work anymore. We have to use R, so I put R to say remote. And there on the remote machine, this one, I'll connect to it via port 2300. And on the NAS machine, the server here locally, I will access 127.0.18000. Due to the fact that is my Python server, I am in charge of its maintenance and operation. Mistake, forgot. Put colon between two, thus it's R2300, 2.127.0.0.18000. There you saw, both are connected. There is a session that has been established. Now here I am, whether I put localhost, the name of my machine or my IP, I launch, hop, there you go. It gives me access to my web server just like earlier. So this is how you establish a reverse connection, which can be quite useful because it allows you to make a downward connection. That is to say, you start from the machine behind the problematic network and you cross over to reach your client, your personal machine, let's say, which offers you access, or at least from which you will be able to access the service. I don't know if I'm clear about this kind of thing, but it works both ways. It's cool. The idea is always to access from machine A to the service of machine B, or to the services behind machine B, except that we can do it either like this or like this. That is to say, establish the connection in this direction, and then from this machine be able to query what is happening behind the server calmly. Here is the demo. I will also provide a small link that gives other examples, especially for dynamic power forwarding through socks or dynamic reverse through socks. There are details, etc. Be aware that Chisel is capable of running in the background. It is a tool that can be left running on a machine, and when needed, it can be called and used in that manner. And there you have it. That's how you make tunnels. You see, it's not really complicated. It's just about ports and IP addresses. You can throw in one direction or the other. There are options I haven't mentioned, but I'll let you go look if you want. At the server level, you see we can put authentication keys. We can also generate keys with the keygen parameter. I was mentioning key, but that particular one is deprecated. It is now key file. Here you can specify a private key file. If you're bothered by keys, you have hot file to specify users and passwords, logins, passwords as you wish. And then there are other parameters like keep alive, which enable establishing and maintaining the connection for a specific duration of time. The backend option allows you to specify the existence of another HTTP server to proxy requests. By adopting this approach, it avoids drawing attention to Chisel during its execution on a machine. That's all for options. Then there's matter of TLS certificates, etc. And on client side, we have same examples. So what I showed you earlier with R for remote, which replaces, let's say, 127.0.0 in any case. Possibly interface, ports, and then same thing in other direction on other side. Here are some examples here. They give examples of possible remotes. So either the port alone, or a domain name with a port, or a port, a domain name to port 80, IPs, SOCKS type protocols. We even have things like that with UDP, etc. for requests. Lots of docs to do. I'll let you go and check it out. Found the tool interesting. That's why I'm telling you it's practical. This will allow you, like this, in environments that block you or where there is censorship, or to expose things, because you are a developer and you need to access services or tools that you have at home, in self-hosting simply, and be able to access them securely from anywhere. It can also be a good method for you to create your own secure network at a lower cost, directly with tunnels, somewhat similar to that. There you go. Hope you found it interesting. Thanks for your support, friends. Hope to see you on patreon.com. Subscribe to YouTube. If you're watching me, don't hesitate to leave a comment. Subscribe to the channel, as I have videos I release almost every week on various topics. If you have topics you want me to cover, let me know. I'd be happy to explore. As for me, I wish you a good end of the week. See you soon. Bye.